Science 1, Standard 9, Topic Work and Energy. Today we are going to learn in details about free fall and that is, the object is falling towards the earth under the influence of gravitational force. If we release an object from a certain height, it will get pulled towards the earth under the influence of gravitational force. Here only gravitational force is acting, no other force is acting. So the object is said to be in free fall or to be falling freely. If we release an object from a height, it gets pulled towards the earth because of the gravitational force. An object falling solely under the influence of gravitational force is said to be in free fall or to be falling freely. As shown in the figure, the point A is at a height h from the ground. Let the point B at a distance x vertically below A. Let the point C be on the ground directly below A and B. Now we have to calculate the energies of the object at point A, B and C. Let us calculate the kinetic and potential energies of an object of mass m falling freely from height h when the object is at point A. Now when the object is stationary at A, its initial velocity is u is equal to 0. Therefore, kinetic energy we know it is half into mass into velocity square. Half into m multiplied by u square. Why? Because initial velocity is u. Now kinetic energy is equal to 0 because initial velocity is 0. So anything multiplied by 0 will be 0. Potential energy, as we know, it is mgh. Therefore, total energy is equal to kinetic energy plus potential energy. Now, kinetic energy is 0 plus potential energy is mgh. Therefore, total energy will be equal to mgh. This is our equation number 1. Let the velocity of the object be Vb when it reaches to point B, having fallen through a distance x. Now here initial velocity is equal to 0, distance is equal to x, acceleration will be equal to g, that is acceleration due to gravity. Now we will use Newton's third equation of motion, that is v square is equal to u square plus 2as, and we will put the values in it. Here we are finding the velocity at point B, so velocity will be equal to vb square. Initial velocity is 0 plus 2gx. Now Vb square will be equal to 2gx. We know kinetic energy is equal to half mv square. Now here it will be half mvb square because we are finding velocity at point P, and we will put the value half m 2gx. 2 will get cancelled, so kinetic energy will be equal to mgx. Now, height of the object when it B will be equal to total height minus x. So, it will be h minus x. We know potential energy is equal to mgh. So, instead of h, we will write h minus x. We will open the bracket. So, potential energy will become mgh minus mgx. We know total energy is equal to kinetic energy plus potential energy. So kinetic energy is mgx plus potential energy is mgh minus mgx. So plus mgx minus mgx will get cancelled. Hence total energy will be equal to mgh. This is our equation number 2. Let the velocity of the object be vc when it reaches the ground near point C. Here initial velocity is equal to 0, distance is equal to total height h, acceleration will be equal to g, that is acceleration due to gravity. Newton's third equation of motion is v square is equal to u square plus 2as. Now we will put the values in it. Here we are finding velocity at point C. So it will be vc square is equal to 0 plus 2gh. Now 0 plus 2gh will be equal to 2gh. So velocity at point C will be equal to 2gh. Now kinetic energy is equal to half mvc square. Now half mvc square is 2gh. Now 2 will get cancelled. So kinetic energy will be equal to mgh. Now potential energy, the height of the object from the ground at point C is height is equal to 0. So potential energy will be equal to 0 because height is equal to 0. Now total energy is equal to kinetic energy plus potential energy. So kinetic energy is mgh, potential energy is 0. So total energy will be equal to mgh. This is our equation number 3. From equations 1, 2 and 3, we will see that the total energies of the object at all the 3 points, that is A, B and C, are same. Total energy is nothing but kinetic energy plus potential energy. So total energy at point A is 0 plus mgh, which will be equal to mgh. Total energy at point B is mgx plus mgh minus mgx. So plus mgx minus mgx got cancelled, it will be equal to mgh. Total energy at point C is mgh plus 0, so it will be equal to mgh. So from this derivation we will see that the total energy at any point during the fall remains constant, and what is changing? Potential energy and kinetic energy is changing. So when the object is at a height h above the ground, the potential energy will be maximum, and when the object is falling towards the ground, the potential energy will be converted to kinetic energy. So at the ground near point C, the potential energy was 0 and the kinetic energy was maximum. Think before you answer. Can your father climb stairs as fast as you can? Now, when two persons are climbing the stairs, the one person can be fast and the other person can be slow depending upon their capacity to do work or energy. This overhead water tank will be filled fast with the help of a bucket or an electric motor. So obviously the answer is it will be filled faster with the help of an electric motor. In the last two examples, we have seen that the work done can be slow or fast. Thus, the fast or slow rate of the work done is expressed in terms of power. Power is defined as the rate at which work is done. If W amount of work is done in time t, then power is equal to work upon time. Therefore, P is equal to W upon T. In SI system, the unit of work is joule. Hence, the unit of power will be P is equal to W upon T. So, the unit of work is joule. Time is second. So the unit of power is joule per second. Now this joule per second is also called as watt. Joule per second is called as watt. 1 watt can be written as 1 joule upon 1 second. In the industrial sector, the unit used to measure power is called horsepower. 1 horsepower is equal to 746 watt. The unit of energy for commercial purpose is kilowatt hour. when 1000 joule work performed in 1 second is called as 1 kilowatt power. 1 kilowatt hour is equal to 1 kilowatt multiplied by 1 hour. We know that 1 kilowatt is equal to 1000 watt and 1 hour is equal to 3600 seconds. Hence, 1 kilowatt hour will be equal to 36 lakh joule. 1 kilowatt hour can also be written as 3.6 multiplied by 10 raised to 6 joule by laws of indices. Now, electricity used for domestic purposes is measured in 1 kilowatt hour will be equal to 1 unit. An introduction to scientist. James Watt was born in 1736 and died in 1819. He was the one who invented the steam engine in 1781. This steam engine brought about an industrial revolution. The unit of power is called watt in his honor. James Watt was the first person to use the term horsepower. Now we will solve some numericals based on the concept power. Example 1. A 25-watt electric bulb is used for 10 hours every day. How much electricity does it consume each day? So first we will write what is given. Given is power, that is 25 watt, and time is 10 hours. Now time is already in hours and power is in watt. So we will convert power in kilowatt. So 25 upon 1000 will be equal to 0.025 kilowatt. Now we know that power is equal to work upon time. Work is equal to energy. So we can write power is equal to energy upon time. So energy will be equal to power multiplied by time. That will be equal to 0.025 multiplied by 10. So energy will be equal to 0.25 kilowatt hour. So the energy consumed by electric bulb will be 0.25 kilowatt hour. Example 2. Sorali takes 20 seconds to carry a bag weighing 20 kg to a height of 5 meter. How much power has she used? First we will write what is given, that is mass equal to 20 kg, height equal to 5 meter, time equal to 20 seconds. What we have to find out? Power. We know the formula of power is work upon time. But here we don't know how much work is done. So first we will find out work done, that is force multiplied by distance. Here again we don't know how much force has been applied. So first we will find out force, that is mass into acceleration. Here it will be mass into g, that is acceleration due to gravity. Mass is 20 kg, acceleration due to gravity is 9.8 meter per second square. Now when we will multiply it, it will be 196 Newton. Now work done is F multiplied by S. So it will be 196 multiplied by 5 meter. It will be 980 joule. Now we have find out how much work is done. So we will put this in the formula of power. Power is equal to work upon time. Therefore work is 980 joule. Time is 20 second, which will be equal to 49 joule per second, or we can write 49 watt. Hence, Sorali has used 49 watt power to carry a bag weighing 20 kg to a height of 5 meter.